Welcome to the video lecture series of Theory of Computation. Today we are going to study about the introduction about context-free grammar. I am your instructor Poonam Patel. Let's start to understand this topic by using the introduction, definition and using the example we can understand this topic. Now, before going into detail, we need to know what is grammar. So we can say that grammar is a set of rules which used whether the string is belong to particular language or not. So we can say that a grammar is a rules which are used to identify the strings, and we can say that by using the grammar we can say that no, this string is belongs to a particular grammar. Now next thing, what is context free grammar? So context free grammar, we can say that it is a one formal grammar which is used to generate all possible patterns of the strings in a given language, in a given formal language. So we can say that it is a formal grammar which are used to generate all possible patterns of the strings which belongs to that particular language. Now let us understand what are used to where the context free grammar is used. So we can say that the context free grammar is used to design the parser. Parser is a we can say that a derivation tree syntax which is called as a syntax tree. So for the this parser is basically a part of the compiler. So we can say that the context free grammar is used to design the parser. Now next, what is the formal definition of context free grammar? So we can say that context free grammar is defined by the four tuples. What are that four tuples? So we can say that N, T, capital P, S. Now N is, we can say that capital N is a set of non-terminal symbol. Basically we can this set of non-terminals we can define by the capital letters mostly. Now next is T, terminals. Basically terminals we can define by using the lowercase letters. Operators are used as a terminals. We can say that small letters we can use to define the terminals. Now the intersection between the non-terminal and terminals, the intersection between non-terminal and terminal are 5. It means that there is a no common symbol used in a non-terminals and also terminals. So there is no common symbol. The symbol are separated, the non-terminals and terminals. So what is that? That we can understand, that we will understand this non-terminals and terminals by using the example in the next slide. Now next is, what is a P? So as we already discussed, grammar is a set of rules. So this P is a production rules which are used for generating the strings. Now we can see over here P colon N tends to N union T star. Always remember these things. As you can see over here, this one, this is important thing. N union T star. This is cleans closure. Now always remember this, in a context free grammar this is a particular production rule should be in this form. Okay, so we can say that the left hand side symbol always contain the left hand side symbol. Okay, now you can see the left hand side symbol always contain non-terminal symbol, and the right hand side of this arrow you can see this is N union T star. Okay, now they said that the combination of non-terminal or terminals, it can be appear on the right hand side of arrow. Okay, so left hand side of arrow, this is arrow, the left hand side of arrow is always contains single non-terminal symbol, Okay, and the right hand side any combination, and union T, it means it may be contain non terminals or terminal symbol, and that will be a star. Star indicate this symbol is repeated 0 or more times, so it may be contain, so it may be contain a null string. If star, if we represent this like this, and it may be happen like this, null, we can say that. So this is called the star. In place of we put, if we can see, okay, so in place of r, so in place of we can say that in place of star, if we put n union T 0, okay, so it means that it contain null string, okay, like this, it may contain null string. So okay, so this is, remember, n tends to n union T star. So star, it means that the right hand side is contain non-terminal and terminal symbols combination, and the left hand side should be contain a non-terminal symbol. So this is the format for the context free grammar. Okay, now last thing is S. So we can say that S, what is S? S is the start symbol. So the symbol which are used for a which are used to generate the strings. Okay, so I think this formal definition is clear to you. Now let us understand this formal definition by using the example, so you can get the clear cut idea about this. Now this is the example where I have defined the grammar. Now you can see over here, this is the grammar. Okay, now you can see over here, uh, this is uh, this is production rule. So this is actual contain 3 production rule, A tends to B, and A again tends to C, capital C, like this. Okay, and next is B and capital C, this is small c. Okay, so this is called the grammars. This is context free grammar. How we can identify this is the context free grammar? So context free grammar, the production rule form, what is said that the left hand side should be single non terminals. Now what is non terminals, what is terminals? So we can so here you can see the capital letters I have used, B, A, capital C, capital B, capital A. So in this grammar, the non terminals N dot T, it means that the non terminals for this grammar is A, capital B and capital C. Always how we can identify it? So always remember this, the left hand side symbol that I have used over here, this is all are called as a non terminals. Basically normally it is defined by the capital letters. Okay, now next is what is terminal? So the remaining symbol which are not non terminals, which are not included in a non-terminals, are called as a terminal symbol. So in this grammar we can say that our terminals are T. It means the terminals are small a, small b and small c. Okay, like this. So small c. So here you can see. So for this grammar there are two things you need to identify. The first one is non-terminals. So simply you can see in this grammar the left hand side symbol all are included. If it is context free grammar, so all left hand side symbol for the given productions is included in the non-terminals, and the symbol which are not included in a non-terminals are included in a terminals. So basically we can say that in a terminal symbol are defined by the lower case letter and non-terminals defined by the upper case letter. Okay, so here you can say that the grammar contains four things. The first one is non-terminals, second is terminals. P, it means the rules, production rules, and the last one is start symbol, which is called a, we can say that a capital A. In a previous slide we have defined by capital S, you can also say capital A, which is our start symbol. So here I have defined the production rule. So this is my production rule, all rule. Okay, so as we know, A tends to A, then A tends to B, this one, and last one is, okay, like this one, and B derives B and capital C derives C. So we can say that A derives small a, capital A derives small b, capital B, A derives small c, capital C, and B derives small b, capital C derives small c. So in this way we can define the symbol. Now A is the start symbol. In this example, the first production in this grammar, the first productions, the left hand side symbol, which is a non-terminals, and this is in this grammar is a start symbol where you can start for generating the strings. So this is the start symbol. So in this grammar, our start symbol is capital A. Okay. In a previous slide, if we discussed about the formal definition where there are four types: the non-terminal, terminals, production, and S is start symbol. So what is the start symbol for this grammar? So in this grammar, we can say that capital A is the start symbol. Now next is derivation tree. A derivation tree or path tree is an ordered tree that graphically represent. So what is a derivation tree? So we can say that a derivation tree is also called as path tree, is an ordered tree that graphically represent the semantic information, a string which derived from a context-free grammar. So the string which is derived from the grammar, if we represented in a tree form, is called as a derivation tree. Now how we can generate the derivation tree? What component, what are the nodes that derivation tree contains? So representation technique for the derivation tree is, first is root vertex. Now the root vertex, the node which is always the topmost symbol, which is always start node, is considered as a root vertex, and the start node always must be a start symbol. The grammar the start symbol of the grammar must be situated at the top in the tree, in the path tree. Okay. The next is internal node, and all internal nodes in the tree are labeled by the non-terminals. Always remember like this, you can see. And the last one is leaf node. What are the leaves node? So leaf node are labeled by terminals. So always remember three things. Now let us understand this concept, derivation tree concept, by using the example. So here you can see, this is the one context tree grammar is given, and I want to generate the derivation tree. Derivation tree normally used for the representing string which is derived from the given grammar. Now, so first of all, we need to understand what are the non-terminals and terminals contained in this grammar. So you can see in this grammar, this as, this is context free grammar. So that's why all left hand side, this arrow, this is left hand side. So S, B and C, all are my non-terminals. Okay. S, B and C. Okay. Now terminals, so the remaining thing are included in this. What are the small letters? A, B, C, and also included the null string. Okay. Now what are the start symbols? So the first production which contain the non-terminals, the left hand side, is called our start symbol. So for this grammar, the start symbol is Okay. Now you can see over here in this example, I want to generate the strings. Now I want to generate the strings. Suppose I want to generate the strings AB. Now always remember, string are always contain the terminal symbols. Okay. Now I want to generate the string AB by using the derivation tree. So as we discussed in a previous slide, the derivation tree where the root node always contain the start symbol, the internal nodes contain the non-terminals, and the last leaf node which contain the terminal symbol. Okay, so how we can construct the derivation tree for the string? So in this example you can see, first start from the S. Now S expand where this is the topmost node. Now I am moving from top to bottom. Now how we can move? So we need to use the node which you are going to expand. We need to use those node productions. It means that in this grammar, okay, now I want to expand S. Okay, now how we can expand the S? So S, I have three choice: A, B. Either you can use the production of S, like because I am going to expand the B, always we can expand in this derivation tree, we can expand the non-terminals always. Okay, and last one is S derives C, and always expand is start from the start symbol. Okay, so we can make the branch of S by 2, the one. So here the first, if you see in the string, the first symbol is small a, so we need to A, B. Okay, now if this node is contain terminals, so we cannot expand it. We are always going to expand only non-terminals. Okay, not a terminals. Why non-terminals? Because non-terminal contain the productions rule. Okay, now A, this is terminal. Now B. Now how we can expand the B? So by using the production of B. B contain only one production. So directly we can expand the B. B derives small b. Okay, can we expand this node? No, because it contain the terminal symbol. Okay, so because it contains the terminal symbol, so we cannot expand it. So now can we further derivation tree expand? No, we cannot expand. So our derivation tree is like this: A, S derives small a, B, and B derives B. Now what is the resultant product for the this derivation tree? So in this derivation tree you can see we need to read the all leaf node from left to right, all leaf node from like this. You can see now this is leaf node appears. Which terminals is contained? Leaf node A. Left to right you need to go from top to bottom like this. Now again leaf node appear. Which symbol is contained? It contains the terminus B. Now reading from left to right, go from the top. Okay, so we need to read the leaf node from left to right, or leaf node. All leaf node we need to the derivation tree which contain the leaf node, we need to read the leaf node from left to right, and this leaf node in a sequence is called the string. Okay, so in this way we can represent the derivation tree. So as we understand the derivation tree, this is called the topmost, which is a root node, and root node always contain start symbol. So in this grammar our start symbol is capital S. If you see the internal nodes in this derivation tree, our internal node is B, which is a terminus, and terminus you can see over here A. This is our leaf node which contain the terminals. And what string it generates? Read the leaf node from left to right, you can get this string which is derived from the given derivation tree. So I hope this concept is clear to you about the derivation tree. Now there are two ways we can generate the derivation tree. From derivation tree, the two approach. The first approach is a top down approach, where you start generating the tree from top to bottom, which is which we have already discussed in the previous slide. Okay, which we have discussed only in the previous slide. And what is the bottom up approach? So bottom up approach is said that we are start from the leaf node and going upward from the root node, like this, bottom to top. If we are constructing the derivation tree, start from the leaf node going to the topmost node is called the bottom up approach, and if you are generating the derivation tree from top to bottom is called the top down approach. So as we as we have seen already in previous slide, it is called the top down approach because we are going to generate the strings by topmost node to leaf node. Now let us understand what is a bottom up approach. So here you can see like this, suppose. So as suppose this is, I have taken one simple example so you can get the clear cut idea about this B. Okay, my string is my string is for this grammar AB. Okay, so AB, so my string is AB as derived small a, capital B and B. Now how we can start the generation? AB, start from the leaf node, this is my leaf node, 1, 2. Now use the productions. So small b, now is there any terminals which is any right hand side of non-terminals? Yes, so we can reduce it. This b, small b is reduced by capital B. This thing you need to understand, so that's why I'm discuss only these things, how we can generate it bottom up approach. Okay, so b reduced, small b reduced by capital B. So we have to see the right hand side production of this leaf node. Is there any right hand side production is contained this thing? If yes, we can reduce it by the non-terminals. Okay, now next, right now what we have, A and capital B. Okay, so can we reduce A capital B? Is there any productions which contain the right hand side small a capital B? Yes, you can see over here this is. So we can reduce this by S. This is called the bottom up approach. So I hope, so this is called the bottom up approach. So we can say that there are two approaches for the derivation tree, top down and bottom up approach. Okay, so I hope this concept is clear to you. Thank you all.